Welcome to Unit 3, Lesson 3, Graphs of Rational Functions, Part 2. Let's learn about horizontal asymptotes. All right, now, yesterday we briefly touched on vertical asymptotes, but now we're going to talk about horizontal asymptotes. But don't forget, when you see rational, when you see the word rational, that tells us we have a fraction. So yesterday we did vertical asymptotes. Today we're going to do horizontal asymptotes. Decide if each of these equations is true or false for x values that do not result in a denominator of 0. So basically don't put 0 in. So now what you have to remember here is our fraction rules. If you have x plus 7 in the numerator, we can separate this to x over x plus 7 over x. And if we divide x divided by x, we get 1 plus 7 over x, which gives us the right side, 1 plus 7 over x. These are equivalent, so this one is true. Okay, let us do number 2 in a different color. All right, so x plus 7, the x plus 7 is in the denominator. We cannot separate this one. So these are two different functions, and this one is false. They're not equivalent. Because if you put 0 on the left side, you'll get 0. And if you put 0 on the right side, you'll get 1. So these are not, there are no numbers that will make these equivalent. Okay, so we're going to use this equation for this problem. 120 plus 4x over x. So now, let's see be the function that gives the average cost per book. So, as we see, total books printed is our y, cost per book is y. Total books printed is our x. That's our input, cost is our output. Now, we have an asymptote at 4. And how do I know the asymptote is at 4? Because I can see the line bending right here at 4. And we have a vertical asymptote at 0. Because if you set x equal to 0, x is just 0. So now, as the books printed goes up, the price goes down. It approaches $4. It never touches it. As you print less books, the price goes up. And that kind of makes sense. Okay, now we can use this graph to answer the questions on the next page. You might have to refer back to this for the next questions. What is the approximate cost per book when 50 books are printed? So basically what you do is you put a dot at 50 books, you run up the line at 50 and intersect it with the graph, and we could say it's about 50 books. So let's do 50 books in purple. Let's do 100 books in red. And so 50 books was about, you could calculate it, but it's about 6.3, about. It's about 6.3. That means $6.30. And then for 100 books, we go to 100, we go up to the graph, and that's probably about 15, about. If you put it in the calculator, you will get much more accurate answers. And then you will have to change, you will have to do a lot of stuff. Put it in the calculator, you can do it. So now, the author plans to charge $8 per book. How many books should be printed to make a profit? So $8 is an output. This is cost. So what you do is go to 8 on the y-axis and go over, go to 8 on the y-axis and go over to the left till you hit the graph and then go down. And we can see that the price per book, the cost per book is 8. How many books would need to be printed? It's about 30. Now you can put these numbers right into the calculator and see and get a more accurate thing. So now, what is the value of C of x when half of book is printed, when x equals half? So that's half a book printed. So if you stick 1/2 in for x, you'll get about 140, 150, somewhere around there. Now, how does this relate to the context? You can print half a book, but you can't sell half a book. So this is not a real answer. What does the end behavior of the function say about the context? So less books printed as x goes to 0, which means less books printed. You get higher costs. That's the outcome. Okay, as more books get printed, you have a cost goes to $4. Cost goes to, because we have an asymptote, to $4. Okay, now horizontal asymptotes. These problems are very similar to the one from the warm-up. So now, for C, F, E, and D, C, D, E, and F, we can separate these because they're added. So if you put 1 over x plus 4x over x, and that cancels out, and you get 1x plus 4. For D, if I do x over x plus 4 over x, that makes 1 plus 4 over x. For E, if I put 1 over x minus 4x over x, the x's cancel out, and I wound up with 1x minus 4. And for F, if I do 4 over x minus x over x, these cancel out. I get 4x minus 1. Now, A is the same as F. Okay, so let's highlight these. A is the same as F. B is the same as E. B is the same as E. They'll just look different because they both have denominators. And then C, 1 over x plus 4, 1 over x plus 4. Is the same as H, and then G is the same as D. Okay, so now that we did this, we can graph these, and now we can see which one matches. Here are 4 graphs. All right, let's match these to the graph. Put these in a y equals, graph both of them, and graph A goes with C, I'm in the wrong thing. It goes with C and, C is in blue. Sorry. C and H. Okay, graph B. Graph B was in red. Graph B goes with E and B, because I put these in the calculator. Okay, graph C. Graph C was blue. Graph C goes with D and G, D and G. And finally, graph D was purple. So it goes with A and F. So put them in the calculator. You know how to graph this stuff in the calculator, but you have to know which ones are equivalents. Or you could just graph them, all 8 of them. But if you know how to separate them using your fraction law rules, then it'll make this task easier. Part 2 of this question, where do you see the horizontal asymptotes? Okay, so the dotted line, which will not show up on the calculator, is the horizontal asymptote. And that should give us a hint of how to find the horizontal asymptote. Okay, so finally, let us highlight this whole sentence today. So let me take one of the problems from the previous one. So if I take function A from the previous one, so A was 4 over x minus 1, and then its equivalent was f, which was 4 minus x over x. Okay, so basically, this is how this works. What you're going to have to do is separate them. So because we have an expression in the top, we can separate these. 4 over x minus x over x. And when we divide by x divided by x is 1. So this is 4 over x minus 1. And this is how A and F are equivalent. We know that as x gets bigger, this one is going to go to 0. So our horizontal asymptote was -1. And that's why we saw graph D was like that. So whatever whole number is left over, that is your horizontal asymptote. So when you factor out the x's. So let me do one where the x was next to a letter. So let me do C, which was equivalent to H. So let me do that in a different color. Okay. Let's do this in red. C was 1 plus 4x over x. If I separate them, I get 1 over x, which goes to 0 as x gets bigger. We're talking about in behavior. 4x over x. If you cancel out the x's, you're left with 4. This is your horizontal asymptote. Or 1 over x plus 4, which was h. C and h went together. Your whole number that's left over after you separate the fraction is your horizontal asymptote. This is how you find a horizontal asymptote.